Problem number 4 of our IR practice. All right, so once again, this is from online. I did not generate this problem. I don't know what the answer is. So again, just thinking about what I know. I can go ahead and I don't even have to mark my regions because I already see this right here. When it's nice and beautiful, I expect this to be alcohol. So I'm going to go ahead and get rid of B, D, and E. All right, that is a very typical shape for an alcohol OH group. Now I'm going to start adding in my regions. So 15 to 2000 is my sp2, 2500 is my sp, and then I have hydrogens here. I don't really have a whole lot going on here in this IR. All right, so now the only thing I'm trying to figure out is, do I have a double bond or do I not have a double bond? All right, so this is where you guys would start emailing me in a panic because you see I see something here. I'm very hesitant to believe that this is anything significant. All right, you could argue with me. You could argue all you want that there's a double bond here. What would verify that for me is, are the hydrogens of this double bond present in the IR as well? So if we look around 3000, I can see these peaks right here. Those are corresponding to the hydrogen on an sp3 hybridized carbon. I don't see any peaks for an sp2 carbon hydrogen. That would be slightly above 3000. I don't see those there, so I'm prone to think that the answer is going to be A here. All right, so I would think that these are not significant or relevant to this IR. So that's how I start distinguishing, is that peak important or not? I would look at the other peaks that would confirm the presence of that. All right, but I already had my doubts just because they're so wide, and a carbon-carbon double bond is usually pretty sharp, right? It's not going to be wide and broad. Broadness mostly comes from hydrogen bonding. All of our peaks that we've seen in sp2 and sp have usually been pretty narrow. So that's one of the ways that I factor out peaks that aren't relevant.